Hey guys, this is the TI-84 guy. I'm back. It's been a while since I've created a video that demonstrates a program that I've written, but I wanted to put this out for the summer. This is something for the new SAT, ACT, or if you're taking Algebra 1 or Algebra 2 and you have to do factoring of quadratics, this program will help. Okay, let me just jump in. All right, so right here we have a standard quadratic in with the leading coefficient of 1, and it's asking you to factor it. It's pretty simple. Most students can handle this, but I've written a program that helps to factor. Okay, so it'll come up with these options. It's called FactQuad, by the way. It'll come up with these options, and we're going to choose the standard one because we want the standard one, option 1. So it says, what's the A term? It's 1. What's the B term? It's a -7. What's the C term? It's a -18. Press enter, and we want to, now it's asking us what do we want, what form do we want it to come out in. We want it in the factored form, so we factor it. If it's factorable, it is. Tells me that the factors are x minus 9 and x plus 2. Pretty straightforward. Now, here's the thing that's pretty nice about it is that you can go the other way as well. You can go from the factor to the standard. All right, so now if we look at this one, we've got px plus 2, p minus 7. So we're going to choose option 3 for factored. We're going to put in the leading coefficient, in this case is 1. So we're going to put in 1. And then we're going to put in 1 again. Then we're going to put in 2, the constant. And then the next coefficient is 1. And then we have -7. All right. Put that in. Press enter. Now we want the standard form. We want this form. So we're going to choose option 3. So it puts the factored form at first, and then it puts the standard form underneath it. Okay, pretty straightforward. Now, here's where it becomes really valuable. When you have something that doesn't have a leading coefficient of 1, for instance, this one, number 5. We're going to take in the standard. The leading coefficient is 7. The B term is a -31. The C term is a -20. All right. Now we want to factor it. Choose option 1. It's working. There it goes. It says the factors are x minus 5 and 7x plus 4. Pretty straightforward. Now let's go the other way, just to show you that it can go the other way, even if the coefficient is not, leading coefficient is not 1. So we're going to put in factored. So we're going to put in 1 here. We're going to put in 7 for the coefficient. Going to put in a 4. Going to put in a 1 and then a -7, and we're going to press enter. And now we want the standard form, so we choose option 3, and it foils it for us. So we got 7x squared minus 45x minus 28. Okay, now here's another one. Here's some exceptions. Okay, right now, problem 6 here, it says 7k squared plus 9k. Now, most of you should know that you could just factor a k out. So you're left with k plus 7k plus 9. But I just wanted to show you that the program can actually handle those as well. So we're going to choose standard. We're going to put in 7 for the leading coefficient. We're going to put in 9 for B. And then we're going to put in 0 for C, since there's no constant there. And we're going to factor it. And it factors it x times 7k x plus 9. So that handles it when there's no constant. Now, I wrote a little program, another problem over here to show you that if there's no middle term, it can also handle it if the terms are perfect squares. Okay, so look, this 4x squared is a perfect square, 9 is a perfect square, and we got a minus. So this is the difference of perfect squares. So what we can do is we can press enter. We're going with the standard. It's going to be 4 for the leading coefficient. It's going to be 0 for the B term, and it's going to be a negative 9 for the C term, and we want to factor it. So we press enter, and there you have it. 2x plus 3, or tx minus 3, 2x plus 3. We got it. It's factored. Pretty simple. Now, here's one where you have to be just a little creative. So, let me get this in here. So we have 28 n to the 4th plus 16 n cubed minus 80 n squared. Now, this is not a quadratic, but if you notice, you can factor out or prefactor it n squared. Actually, you can factor out a 4n squared. But if you didn't see the 4 part, but just the n squared, you can use the quadratic form, or you can use this quadratic program. So let's go. We're just going to put in the coefficients. So we got the standard. We got 28. We have the B term is 16. And the C term is going to be a negative 80. We press enter. We want it factored. And it factors out the 4. And since we factored out the n squared, it would be 4n squared, 7x minus 10, x plus 2. So that's pretty straightforward, and it works. All right, so now let me show you one last thing about factoring. I got a bunch that I wanted to show, so I'm not sure I'll be able to get them all in here. I just wanted to show you what happens when it's not factorable. Okay, so we press enter. Standard form, leading coefficient is 9. The B term is a negative 5. The C term is a negative 10. We want to factor it. Choose option 1. It's going to search. Says it's not factorable. So that's handled. Okay, now here's where I think this program becomes more valuable. It also handles when you're trying to go from standard to vertex, or from vertex to standard. So let me show you, demonstrate that real quick. Here we have number 1. It says x squared plus 16x plus 71. And they want us to put it in vertex form. So we're going to put in a 1 for the leading coefficient, 16 for the B term, and 71 for the C term. Now we want, this case, we want to choose option 2, the vertex. So we're going to choose option 2, and there we have it. The vertex form has a x coordinate of a negative 8 and the y coordinate of 7. So the vertex is a negative 8, 7. All right, so now let me show you the other way. So we're going to go from the vertex form to the standard form. So press enter. So we're going to choose option 2 here. We're going to put in the a, which is 1. And now we're going to put in the x variable of the vertex, which is, this says minus 1. So we're going to put in, that means the x coordinate is actually 1. So we're going to put in a 1 for h, a positive 1, and then we're going to put in a negative 6 for k. Press enter. Now we want it in the standard form, so we're going to choose option 3, and there we have it. It's going to put it puts in the vertex form, and then it puts it in the standard form. Now you can always go from factor to standard, or from vertex to standard. But going from standard to vertex or standard to factor depends on if it's factorable, and also if you go to the vertex form, sometimes you'll have some decimals that get a little messy, so that's what makes this a little bit more challenging. So let me look, let's do a couple more problems. It can also handle negative leading coefficients, so let's go here, negative 1, negative 14, negative 59. We want it in the vertex form, so we choose option 2, and it factors it. The vertex is at a negative 7 and a negative 10. A negative 7, negative 10. So when it's plus, that means that the vertex is negative. the x-coordinate is going to be negative. All right, so let's see. What else did I want to do here? Okay, here's another one. This one is actually in the factored form, and I want to put it in the vertex form. So press enter. So we're going to choose option 3 in this case. And we're going to put 1 for the leading coefficient or the term right out front. And then we're going to put 1 for the coefficient of the x term. And then we're going to put in a 5. Then we're going to put in a 1 and then a 4. And then we're going to go option 2. And you notice that it puts it in as 4.5. This has 9 over 2, which is 4.5. I couldn't do the fraction part. That was too challenging to try to do it. And that's what kind of makes this a little bit more difficult, because sometimes you get some fractions that are not nice decimals when you convert them. Negative 1/4 is easy. That's a negative 0.25, so it handles that. But you just have to be careful. That's why I put this note here. If you're trying to go to vertex form, you've got to be extremely careful. Sometimes you'll get a decimal vertex, and the numbers are really messy. So just be careful with that. Now, the real reason that I wanted to go through this is that these quadratics show up a lot on the ACT and the new SAT. So I wanted to go through a couple of quick questions. All right, here's one. Number 11. It says they want you to go from the factored form basically to the standard form. So we're going to choose 3 for factored. We're going to put in 1, and then we're going to put 3, 7, and then 3, 7. And then we're going to go to the standard. So we're going to choose option 3, and it foils it. And it's 9x squared plus 42x plus 49, so the choice would be E here. That's on the ACT. That's from an old ACT exam. Here's another question on the same exam. It was a number 23 question. In this case, we're going from the standard to the factored. So, and the leading coefficient is not 1. That's what makes this a little bit more challenging. So we would go standard. We would put in 5. And then a negative 13, and then a negative 6, and then we want factor, so we choose option 1, and it's going to factor it, so it would be x minus 3, 5x plus 2. That would be choice A. Okay, that's from the an old ACT exam. Now the new ACT, I've noticed that it has a lot of, well, not a lot, but it has several questions that deal with going from different forms of vertex. So in this case, they gave us the standard form, and they wanted us to put it in the vertex form. Okay, so we just go here. We're going to choose standard for our input. We're going to choose 1, and then we're going to put in a negative 2, and then we're going to put in a negative 15. Press enter. Now we want the vertex form, so we're going to choose option 2, and it says that the vertex form is a negative 1, negative 16. That would be choice D. Okay, here's another one from a different new SAT. Okay, number 28 question. The last one was a number 30. So those are a little bit more challenging, but if you have this program, it's no problem. All right, so now this one, it gives you the factored form, option 3. And we want to put it in the vertex form. So it's going to be 1, 1, 6, 1, a negative 4. And then we choose 2. And it tells us that the vertex is x plus 1, negative 25. That would be choice D. We're moving right on along. Okay, now let's see what we got here. Next one here. Now this one's a little bit, first of all, this is in the non-calculator section, but I just wanted to show you that some of these problems could easily be in the calculator section. So, if you are stuck on these problems and you're not able to do it and you go, dang, if I can only use the program. And then you kind of remember what you know, certain qualities of the problem, you can maybe get them later. So here, in this case, we want to take, this is grouping more or less, right? Or we can say it's factored, and we want to put it in the standard form. So I would choose option 3. Now, what I really need to do here, and what I want you to see, is that this would be the same thing as 2x plus 3. And then this would be 3x plus 5. Right? So these are the same thing. So I just factored out a 3x plus 5, and then I'm left with 2x plus 3. So now that I have that, I can use factored, and we got 1, 2, 3, 5, and we want to go to the standard form, so we would go choice 3. So that means our B term would be 19. So 19 would be the answer for this, because that's what they're asking us for. What is the value of B? So B would be 19, and then we're moving right along. Let's see what else we got here. I'm going to wrap this up. This is a little longer than I wanted it to be. Okay, so here, this is just a pretty straightforward. Even though this, again, this is in the non-calculator section, I just wanted to demo the program. Okay, so this case, we have it in the standard form, and they want us to make it into the vertex form. So we would go standard, it would be 1, 6, 4, and we want to go to the vertex form, choose option 2. So it would be x plus 3 minus 5, right here, number 2. And we're off. Okay, let's see what else I got. All right, here's one. Now here's one where you would have, well, I'm going to skip this one because I'm running out of time. Let me see what else I wanted to do. This one is pretty straightforward. It's just the standard. They wanted us to put it in the factored form. When they say x-intercepts, they're saying factored form. So you would just go standard to factored. Okay, it's pretty easy. Now this one here, this one is a challenging one. Now this is in the non-calculator section, so I'm going to say that, right? But as I mentioned before, all of these programs or problems that show up in the non-calculator section could easily be in the calculator section. It's almost an arbitrary choice. But this is a number 17 or number 15. So this is one of the more difficult ones in the non-calculator section. But I just wanted to show you how I would hit this. And since we're running out of time, I'm going to show you. Okay, I would focus on this part over here. So it says we've got a factor, and we put it in the standard form, and the coefficients or the factor terms, the coefficients over here, the factor terms add up to 8. What are 2 possible values for C? So we're trying to figure out what this middle term is. So we got to choose out of one of these. So it's almost like back solving, but using the program. So I know the answer is D, but I wanted to I'm going to show you C first. Okay, so we're going to go and we're going to choose standard, and we want to factor it. So we're going to choose option 1, and we're going to put in 15, and then we're going to put in, let's choose C. So we're going to put in 10 for C, or for, yeah, and then we're going to put in 14 for that last part, and we want to factor it. So we're going to see, can we factor this? So it's working, and it says it's not factorable, so that's not our answer because it's not factorable. So then let's go to D. So we're going to do the same thing. We're going to choose the standard. You're going to go 15, and then we're going to go, in this case now we're going to choose 31. So we put in 31, put in 14 for the last term, and then we want to factor it. So boom, voila, it factors it, and if you look at the terms, 5 plus 3 gives us 8, so that works. So that would be your answer. Now, I just want to show you, if you had chosen 41, it should have worked as well. So we got 15, we have 41, we have 14, and we want to factor it. Again, you can see the terms are still 3 and 5. It still works. Okay, so that would be the answer for that one. Now, again, even though this is in the non-calculator section, I wanted to show you that this is something. Part of what is important on doing well on any of these standardized exams is having confidence, right? If you know how to factor, or if you know, okay, I have a tool that allows me to do this, even though I might not be able to solve it right now, it can generate some confidence. So that's why I'm showing a couple problems that are not necessarily in the calculator section. Now here's the last one that I'm going to do. This is in the calculator section, and this is a circle problem. But what we're really going to have to do is we're going to need to complete the square in order to find the coordinates of the center. So what we would have to do here, let me move this over so you can see. So we can just focus on the x part. So x squared plus 20x. And we can take that and just complete the square. So we're going to take standard, we're going to put in 1, 20, and then 0. And then we're going to complete the square. So we're going to find the vertex. So that means that our vertex is going to be 10. So that means that our coordinate, our x coordinate, is going to be a negative 10. So you got to look for an answer that has negative 10. It would be this one. Now, if you wanted to, you could do y squared plus 16y. Right, and complete the square on that, and you would get, you should get, let's do that. So we're going to do the standard. We're going to go 1, 16, 0, and then we're going to choose option 2. And it tells us that, again, that the coordinate will be, since this is a plus 8, that means that the vertex is going to be at a negative 8. So this is definitely our answer. Now, the reason that I showed you this is occasionally they will give you a problem where you actually have to, like number 27 here. In this case, we're trying to find the radius of the circle, so we would complete the square for this part, and then complete the square for this part, and add those numbers to both sides, and then take the square root of this to find that out. Unfortunately, I don't have enough time to do that. I'm kind of running over, but it would be essentially what we did here, except that the number, let me see here. In this case, we have, what is it? It's a negative 64. So we would add 64 to this side, right? Which would be 44, and then whatever the other term that we add, we would add those two, and that would give us the total for the radius. You would take the square root of that to find the radius. But the most important thing to notice is that even though this is a circle, you can break these pieces up and complete the square on each piece to find the vertex, or if you needed to find the radius. So that's what makes this program especially useful. Even though it's not a quadratic, you can still use pieces of it to help you find this, get the answer for this one. All right, this went a little long. I was hoping to do about 15 minutes, so that's why I was kind of running through this a little quickly. There are a couple more problems that I had, but I think for the most part, I hope you see the value of this program. It's called FactQuad, and if you want this, all you have to do is send me your email, subscribe to my channel, and I'll try to get it out to you as quickly as I can. If you have any questions or comments, just put them in the comment section, and I'll try to respond to them. And since this is summer, I have a little bit more time and flexibility to kind of answer questions and those kinds of things. During the school year, I'm just too overwhelmed with other things, teaching duties and tutoring duties, to answer a lot of questions. But now, since the summer, I have a little bit more time to relax. So hope you liked the video. If you have any questions, if you want the program, just send me your email, and I'll try to get it out to you as quickly as possible. All right, have a great summer, and I'll probably try to put a couple more videos out before the end of the summer. Thanks.